Hi, welcome back to Wednesday's video. Another revision lesson today, but today we're seeing, can I recognise mixed numbers and convert them to improper fractions? That's what I'm going to focus on in my video today. And I've got lots of questions, again in test style, to show you how you would be asked to answer these in a test or in an assessment. My first question for you is a really simple missing table, missing numbers question. So it says, write the missing numbers, one is done for you. And you can see you've got improper fractions on the left and mixed numbers on the right. Pause the video if you'd like to have a go, see how much you can remember, and then check back in for the answers. So, my first one that's done for me is I've got 7 quarters and 1 3/4. And that one is done for us. So, now we've got how many halves is equivalent to 5 1/2. And the way that we convert our mixed numbers is we've got 5 1/2, but we've got 5 wholes, so we've got 5 lots of 2 halves. So I need to do 5 times 2, which is 10, and there is 1 half left over, so I need to add that onto my wholes. How many halves are in 5 wholes, which is 10. Add on the remainder would give me 11 halves, like that. Well done if you got that answer. And the bottom one of 17/5 is how much is a mixed number? So you've got to think, how many lots of 5 can we get out of 17? And that tells us that's our 3 wholes there. But that 3 times 5 is 15. So what fraction is left over? Of how many fifths are going to be left over? 15, 16, 17. So it should be 3 2/5. Again, well done if you got that warm-up question, filling in the missing numbers. And I've got this question that says, write these numbers in order starting with the smallest. 5 quarters, 7 sixths, 17 twelfths, or 4 thirds. So, what do you think we need to do first to answer this question? And I would convert them into mixed numbers to see sort of how many wholes we've got, because that could help us put them into orders. So we're going to do some jottings of 5 quarters. What is 5 quarters as a mixed number? You should all be able to tell me. I can get one group of 4, so 1 whole with 1/4 left over like that. Okay, let's move on to our 7 sixths. Again, I can get one group of 6 out of 7 with a 6th left over, or 1 more left over. 17 twelfths, again I've got 1 and 12, 13, 14, 15, 16, 17, 5 twelfths left over, and 4 thirds would be 1 1/3, like that. Right, but we've got that problem of we've got quarters, sixths, twelfths and thirds to deal with, and we can't compare them to order them because they all have different denominators. But is there a common denominator that we can use that's given to us that would work for all of these denominators? 4, 6, 12 and 3. Have a think. And 12 is a multiple of all of the remaining denominators. 4, 6 and 3. 12 is the lowest common multiple. So we need to do another step here where we need to convert our quarters, sixths and thirds into twelfths. So if I've got 1 1/4, my 1 stays the same. And what we've actually got, so my 1 1/4, my 1 whole stays the same. I've always got 1 whole. But my quarter, we need to put a quarter into twelfths. So let's jot that down here. Putting my quarter into twelfths. So we need to think 4 times what is 12? And the answer is 3. So whatever I do to the bottom, I need to do to the top. So I need to do 1 times 3, which is 3. So what this is actually is 1 3/12. Okay, we've done our one now. Right, now we need to do our 1 1/6, if you like, because the 1 stays the same, but we need to put my 6th into twelfths. And you should be able to see that 6 times 2 is 12, and whatever I do to the bottom, I do to the top. So I'm going to do 1 times 2, which is going to be 2/12. So my 1 1/6 becomes 1 2/12. We're getting there. We don't need to do anything to our 17/12 or 1 and 5/12. So we can move on to 1 and 1/3. We need to put our third into 12ths, find that equivalent fraction. Try and do this one by yourselves and then join back in for the answer. So 1/3 is equivalent to 4/12, because 3 times 4 is 12, so we've got to do the same to the numerator. So what that leaves us with is all our fractions are now in 12ths, so we can compare them directly because we've made them all the same. So they've all got one whole, so that doesn't help us eliminate. So we just need to look at the fractions that are left over, and the question wants them in smallest to largest. So of the fraction parts of our mixed numbers, which is the smallest? And you should all be able to tell me that 1 and 2/12 is the smaller, is the 2/12, that fraction part is the smallest. So in our question, 7/6 is the smallest fraction. What's the next biggest fraction that's left over? And it is our 5/4 or our 1 and 3/12 over here, followed by our 1 and 4/12, which is equivalent to 4/3 over here, which leaves our 17/12, which leaves our 17/12 as the largest fraction. So that's just a way that they would ask you to use your converting knowledge to work out these fractions. Now, you could have skipped the step where we made them into mixed numbers, but you never know. One of these could have been 2 wholes and a fraction left over, 3 wholes and a fraction left over, so that could have helped us to order them. It just so happened that this question where they were all the same, so we had to go even further and then use our equivalent fraction knowledge to put them all into 12ths. Okay? I've got the question. Circle the improper fractions at the top. Pause the video and pick the ones you would circle. Which are my improper fractions? And you should have all had a go. And I've got 4/2. I can straight away see that is an improper fraction. 2/5. Now that's not. That is just a non-unit fraction because the numerator is smaller than the denominator. 10/3. Well, that's an improper fraction. 6/4, that is also an improper fraction, and 4/10, again, the numerator is smaller than the denominator, so that is just a non-unit fraction there. So 3 improper fractions at the top. And then it's asking you, of the fractions at the top, which is equivalent to 1 1/2? 1 1/2. So look at the improper fractions, because we know that we can convert from improper to mixed number. So we're looking at the 3 that we circled. Have a look. Which one do you think is equivalent to 1 1/2? And I was thinking you need to have 1 whole. So you need to think, what can you get 1 group out of? And 4/2 I know is equivalent to 2 wholes, because if we've got 4/2, 1 and 2 is 1 whole, 3 and 4 is my second whole, so it's not going to be that one. So I can discount that one. 10/3, again, we only need 1 whole. So how many lots of 3 can we get out of 10? And we go 3, 6, 9. That's going to be at least 3 wholes, so we can discount that one. Which leaves my 6/4. So if we think about my 6/4, we could draw it like this. Got my holes there. 1, 2, 3, 4. 1, 2, 3, 4. Remember pretending that those are equal. It's quite hard to judge on the board. We've got 1, 2, 3, 4, 5, 6. Have we got 1 1/2 if we've got 6/4? And the answer is yes. So I'm going to put my 6/4 in here. I could have just put that in, but it's always good to check you're working out, check they haven't put a red herring or a trick question in there somewhere. 6/4 though is equivalent to 1 1/2. And now it wants which 2 fractions are equivalent out of all the fractions remaining. So I'm going to rub these out so we're not confused. Now we're looking at all of the fractions, and can you spot 2 fractions that are equivalent, that mean the same? Pause the video and have a go yourselves. So, when we're looking for equivalent fractions, we're looking for multiples of the same number. So I need to look at my relationship. I need to think 2 and 4 share common multiples. In fact, 4 is a multiple of 2, but 4 halves, 6 quarters. 2 times 2 is 4. 4 times 2 is not 6, so it's not those two. 5, what about my 2/5 and my 4/10? Well, I've got to think 5 times 2 is 10, yep, and whatever we do to the bottom, we do to the top. So 2 times 2, is 4. So 2/5 and 4/10 were the equivalent fractions there. Well done if you got that answer. Right, we've got another, you're testing our equivalent knowledge with our improper fractions and mixed numbers. So we've got 17/5 in the middle, and it wants to know how many tenths is equivalent to 17/5, and what 17/5 would be as a mixed number. So pause the video and have a go at this yourselves, and then check back in when you're ready to hear the answer. So first I'm going to do my tenths using my equivalent fraction knowledge, and I know that this relationship between 5 and 10 is that we multiply 5 by 2 to make 10. So whatever we do to the bottom, we need to do to the top. So 17 times 2, we need to do 7 times 2, which is 14. I'm trying to do this in my head. I put the 4 and I hold that 1 in my head because we've got to carry it over. Now we need to do 1 times 2, which is 2, but we need to add on that 10 from my 14, so it would be 34. Always helpful to try and use little tricks to speed up your multiplication when you're doing questions like this, especially when we were timesing by 2 or just doubling. And finally, 17/5. What is 17/5 as a mixed number? So they're already telling us that it's 3 wholes, and we know that because we can get 3 equal groups of 5 from 17. But what fraction would be left over? What's going to be this missing number up here? So we've got 15, 16, 17. So there's going to be 2/5 left over. 2/5 left over. Well done if you got that. Bringing in lots of different fraction knowledge that we've done so far. My last question for you is a word problem, and it says Grace, Ellie and Alfie bought 5 pizzas to share. Grace ate 1.5 pizzas, Ellie ate 1 2/3 pizzas, and Alfie ate the rest. How many pizzas did Alfie eat? So we're adding, aren't we? Because we need to know what Grace and Ellie ate to know what was left over that Alfie ate. So we're adding fractions, or adding mixed numbers in this case, but can we add 1.5 and 1 2/3? We can't, can we? And halves and thirds are not multiples of each other. They don't go into each other. So we're going to have to do some converting for this question. So 1.5, we could use sixths, couldn't we, if we've got 2 halves and thirds. So we could use sixths. So I'm going to convert them into sixths. So remember that the whole numbers always stay the same, and we just need to put this into our sixths. So 2 times what is 6? The answer is 3. We need to do the same to the top, which would be 3/6. We should have been able to spot that. If it's 1.5, we want to put it in sixths. 3/6 would have been our answer. So up here, we know that Grace ate 1 3/6. Right, let's do Ellie's share. So Ellie ate 1 2/3. Again, the whole number stays the same. The whole doesn't change, but we need to put our thirds into 6/6. So 3 times what is 6? And the answer is 2. 3 times 2 is 6, and 2 times 2 is 4. So 1 4/6. Now we can add them together because we've given them the same denominator. So we've got 1 3/6. In fact, so first we're going to add the whole numbers first. So we've got 1 add 1, which is 2. So they've definitely eaten 2 whole pizzas, but what fraction have they eaten? So now we're doing 4/6 add 3/6 because of our converting. That was the fraction left over. So 4/6 add 3/6. When the denominators are the same, we can just add the numerators. So 4, 5, 6, 7. If I've got 7/6, what have I actually got? I've actually got 1 and 1/6. So what's my final answer? How much pizza did Alfie eat? Because he ate the rest. We've got to do one more bit of adding. We've got 1 and 1/6, add 2 wholes. So we can ignore the 6th and just think I've got 2, add 1, which will give me 3. So the answer is 3 and 1/6 is the portion that Alfie ate of the pizza. Okay. Have a go at the questions today. There are some mixed number improper fraction work for you to do and some adding and subtracting fractions where the denominators are different. So you need to, as we've done today, make sure that they've got the same denominator in order for you to add them. Best of luck. See you tomorrow.